I'm Beth Peterson. I work on the DS8K. I'm a STSM and master inventor. I have with me the replication expert, Teresa Brown. She's also an STSM and a master inventor, and we've worked on a lot of the technology contained in here. And so I figured, why not have the absolute expert when it gets to safeguarded copy? Okay, now I have to get my doodad. Okay, great. Okay, now maybe we got all of our tech things out of the way. At some point I may go crazy with my charts. That happens every so often, so bear with me. I haven't been out of the house in a while, so this is all getting to be, you know, okay, can I do this without wearing my lounge pants? So I'm pretty happy. All right, so today we're going to cover some of the highlights from our 9.2 release. And I will be putting these charts up as well. So you're welcome to take pictures if you like, but I will put them up as well. We're going to talk about some hardware changes with the new 8980, as well as a number of improvements in our functional feature areas. We've got consistent read from Metro Mirror secondary, safeguarded copy, restore to production, fast creation of safeguarded backup, TCT multi-cloud, guaranteed zeros on space release, local key manager encryption, and GUI enhancements. We're going to start with the new 8980. We have had an evolution of that very high-end option within the DS8K. When you look here over the 88, when it was Gen 1 model for the back end, Gen 2 model for the back end, and now moving to the 8980, that would be the flagship, that would be the most capabilities, the fastest, the most threads. We have other models as well for the DS8K with the 8910 and the 8950 that we've talked about in the past. And there's been a lot of discussion around that initial release. These charts are going to be more focused on the 8980. It's built on Power 9. It's got a larger cache size than the prior 8950. Prior isn't really the right word. The 8950 and the 8910, those are all offerings still as well. It's also got the Gen 2 backend, but it's got a lot more read I/O. It's got more cores in comparison to the 8950, for instance, but it has less cores than prior models. And that's because we're able to have such high response time, or low response time, high improvements in response time, I should say. It's like you want to talk about the negative in a positive way, so the less response, the lower response time, the better. And so we don't need as many cores, which is helpful for footprint and things of that kind. We've got a very low response time using FICON or open distributed I/O with 80 microseconds, and with Z Hyperlink, we have the ultra low latency with 18 microseconds. When you look at our various models, you've got the 8910, which can be both rackless. I think they call it rackable. I have to keep up with the various names that they use now. And so you are able to have that in a system with the smaller form factor mainframe, or the T1 device as well. And so that's helpful if you want to have your own little subsystem in a box. The 8910, that really provides a great solution for smaller environments because we've got the same advanced function across all of the models. So it's great in a test environment where you want to try out new functions, try out new replication, or in a smaller environment where that's, we've got the right size for that environment. It can also come in its own rack. And then we've got the 8950, which it's got most of the same advantages of the 8980. It has a few fewer cores. and it has the max of 3.4 terabytes for your system memory. And then you have the 8980, which has the higher number of cores, so you have more threads for your advanced function, as well as the higher system memory. And we've got some charts on the performance differences to see, what is the impact of 3.4 terabyte cache versus 4.3. So I recently went to some customer briefings, and every IBMer that got up there made a comment, which was basically like, it's an eye chart. And so it's an eye chart. And for those of you in the back, I apologize. And so the slides will be up so that, I'm not going to walk through all of the details, but it's important to have that ability to compare and contrast. And then from a hyperlink perspective, because hyperlink is a synchronous I/O, there are requirements on how many threads we can dedicate to hyperlink in order to balance the rest of the workloads. Now, being a Z hyperlink gal myself, I'd say I'll take all of the threads, but Teresa won't like that. There's replication to be done. And so that's why you've got a variety of configurations there depending on your model. Of course, with the 8900, you've got common family capabilities between having single and three-phase power. All of them are hyperlink compatible. They all use IPDUs, so we no longer have batteries for our non-volatile storage. That's done with NVDIMMs. They all use the previous function authorization models as in the past. They've got the management enclosures with dual HMCs. You can have 16 or 32 gigabyte host adapters. They all use remote code load as the default for microcode upgrades. They've got, the racked models at least have a height of industry 40U to make that very easy and consistent. And you cannot convert from the 88 to the 89. Just so you can have an idea of what they look like, this is the 8980. It's how it's laid out. It's got the 44 processor cores, the 4.3 terabyte of system memory. It can have up to 128 ports for host adapters. You've got a pair of IPDUs. You can do 1 to 8 of the I/O bay enclosure pairs. And the management enclosure will have 2 HSMs and Ethernet switches. Okay, now maybe I already blew my eye chart comment, because yeah, it's another example. This gives you a comparison of the 8880 Fox to the 8980 Fox, and so you can see the size differences. We are constantly trying to improve and simplify. Before on the 88, there was, I think, 9 models. Now we really have 3, 4 if you count rack versus rackless for the 8910, and yet still are able to get really tremendous performance generation to generation. Oh, it's like I knew the next section was performance. So to talk about that just a little bit, this particular chart, we've had this out for a little bit, especially when we introduced the 89 series to give a good breakdown of the performance, of the improvements. One of the things we were really looking to do as well with the improvements was to have the ability to consolidate. So you might be able to move from 4 of a prior model to 1 of the newer models. So we did a comparison really between the 8910 and the 8884. And we see very significant increases in IOPS and also a very impressive reduction in response times. So we also see that when you compare the 8950 to the next model set up, which would be the 8886. Again, significant increases in IOPS, reduction in response time, and really good improvements then. I mean, I guess excellent improvement if you're talking about 71% improvement in sequential performance for reads, or 35% improvement with writes. So, and then again, if you were to compare, kind of flagship to flagship, the 8980 against the 8888, we also continue to see that the IAPs are actually a little bit lower, but that the performance environments will benefit from a 10% reduction in response time. And you will see an improvement in your sequential performance of like 11 to 6%, depending on whether you're running reads or writes. Now, our focus is very much on response time and lowering latency. We're really looking in that sweet spot, as circled here, that of where our customers really run. And in that area, we see an 18 to 25% response time reduction. And that means that you're going to see reduced batch elapsed time. And this is a comparison between the 88 and the 8888, 8980 and the 8888. Okay. Now, I mentioned that there were improvements because of the increases in system memory. So in this particular case, this would be for the 8950, where you have 3.4 terabytes of system memory. We can see that in prior models, if you were running with 1 terabyte and now you're comparing it against 3.4 terabytes, you've got almost a 2.5x reduction in response time, and that means that you're getting a 60% reduction in elapsed time. We also note that because of that improved cache hit ratio, these larger cache sizes will provide higher throughput with that lower response time, and that will increase the consolidation opportunity for many of our customers. Now, when you go to the 8980 with the 4.3 terabyte cache, we continue to see improvements. So now instead of nearly 2.5x reduction in response time, it's nearly 3. And that's going to allow for a 65% reduction in elapsed time. So again, very much in that focus for us for consolidation, really allowing our customers to run that high amount of cache I/O, high throughput with the lower response time. That really allows for some consolidation. So now I'm going to switch gears and talk about 9.2, but before I do, are there any questions on the 8980 that I can answer at this point? And you can always ask questions at the end. Yes.
Can you MES upgrade an 8950 to an 8980?
That's a good question. I would think you can, but I don't know. Actually, don't know the answer to that. Any other questions that maybe I can answer and maybe I can't? Okay. So we're going to talk a little bit about some of the focus areas that we have in the DS8K. And these are areas where we're always looking to enhance our product, to enhance our offerings. We have them in several categories. So one of them is going to be in the ultra low latency. So this is going to be your the hyperlink technology. That's where we're focused for the ultra low latency. Cyber resilience, that's going to be where we are developing and focused on IBM safeguarded copy. From a security perspective, there is the fiber channel endpoint security, the EDIF, the encrypted data in flight, as well as being able to do authentication and authorization of those endpoints. From a cloud and object integration perspective, we have transparent cloud tiering and how it is able to use DS8900 tape object store. From a storage efficiency perspective, we've got thin provisioning and easy tier, as well as workload consolidation. And then from a management and monitoring perspective, we've got our management GUI, DSCLI, REST API. So those are sort of the big categories that we focus on for our functional development. So to show what came out in 9.2 and highlight which areas they're in, put this together. The consistent read from Metro Mirror Secondary does leverage the different characteristics of hyperlink, but it can also be valuable for HPF, FICON connectivity as well. We focus for cyber resiliency on the safeguarded copy restorative production with incremental global copy, as well as a safeguarded copy backup in a cascaded global mirror environment. Security, we have internal key manager for data at rest encryption, guarantees zeros on space release, which would be an improvement over erase on scratch. We also have, with that improvements that we've had around EDIF and endpoint security, one of the things that's helpful is to be able to see what are all of your host logins so that you know how they're configured, who they're attached to. There's ways to generate that information as some handy charts as well. It was important to put it in for endpoint security, but it has a higher value than just that. To be able to have a nice display of where everything is connected is pretty handy. From a cloud, yes. You're good, Roger, to wait.
So wondering, what is the recommendation for doing space releases? How often and why do people do that?
Yeah, from a space release perspective, you really, once you're done with the data and you don't need it any longer in a thin provision environment, it gives you the opportunity to reclaim it. Or if it's the kind of thing where, maybe you've been taking some flash copies and you no longer need that, it's a way to clean that up as well. Sometimes when there are data sets that are being written and then you're done with them, you would do the erase on scratch as you complete that. So before, with the erase on scratch, we would have host commands that we would then need to zero out data. And I think Teresa has some good answers as well.
I was just going to comment that what we do see is we see like a release once a day. The release command will go once a day, go and clear it up. And once you issue it on the primary, it's cascaded all the way down through all the mirroring and so being able to do that once a day helps free up space. So that's what we've been seeing.
Thank you. And then from a cloud and object integration focus, we've got TCT multi-cloud. We've got being able to leverage the DS8700 object store grid replication, and that allows you to extend your disaster recovery into the cloud. We announced 9.2 in July of 2021, and it was available in August of 2021. We have these various summary of what that contained. And I'm going to drill down a little bit more on what some of these are. So from a consistent read from Metro Mirror Secondary, we've had the ability to do a read from the secondary. There were some pretty stringent requirements on it to ensure that you would not be getting stale data. And this was a way to even make it more to really ensure that we do have that consistent read, to know that the data is going to be the same whether you read it from the primary or the secondary. And part of the reason for this is if you are running on your primary and then you were to do a hyper swap to your secondary and you've got different cable lengths or timing changes, then having that impact to your production can be avoided by being able to use the consistent read from secondary, where we are looking very carefully at what are the performance characteristics. And the thing to note about this is, although it came out of the focus around hyperlink, it is beneficial as well with Vicon. Gave a couple of examples of what your system might look like prior to a hyperswap. The other thing to note is that you don't have to do a hyperswap to get the benefit. You may have it configured in such a way that you would get benefit from running from your secondary even before a hyperswap. It does need to be hyperswap enabled so that iOS can know what the mapping is between the primary and the secondary. So that would be an example of the hyperswap and the impact where the new primary is at a distance that is further from your mainframe, and therefore being able to read from the secondary would bring you a performance benefit. You could also have the case that we kind of discussed a little bit as well, which is that you may already have a situation where your secondary is closer, and now once you swap, you'll get the better benefit by using the consistent read. And they will look at things, iOS will look at things in the ICMR behavior to understand kind of what is that. They're going to look at whether or not hyperlink is enabled, where hyperlink is enabled to really make some of those decisions as well. So it's a performance enhancement for Metromir with hyperswap enabled in ZOS environments. And it's got a good benefit for hyperswap even before hyperswap occurs for workload balancing. We will allow the read from secondary only if the Metromir pair is full duplex. We've got a heartbeat mechanism that we use between the primary and the secondary to ensure that there's no surprises on the secondary. We want to make sure that if the primary knows something and the secondary doesn't know it, that we've got a way to communicate and allow them to be, have that consistent ability. And so long as you're in a good state, then we're going to be able to do those reads on the secondary. We have support in Media Manager, IO Driver, and so we're able to have this be applicable for hyperlink eligible reads from DB2, vSAM, and IMS. And you just need the firmware. So you just need the 9.2 firmware. There's no special enablement on the 89. And we have several APARs. Now, I would say, normal caveats apply. Make sure you look at what the latest and greatest maintenance is. Yes, Roger.
I do a lot of disk modeling for customers and whatnot, but I was just thinking with the consistent read coming off that secondary, when I do the modeling, I'm taking a look at reads and writes always for the primary. Is there certain SMF records and things like that are going to be updated for the reads or writes from the secondary?
I will get back to you on that one because we are very focused on making sure that we capture information that's really helpful for modeling.
Okay.
And so I'll get back to you on which SMF records would be valuable for that.
Yeah, I can definitely see this being a big help though, so thank you.
Yeah, good. Yeah, you probably tell from that as well. So I'm going to turn it over to Teresa. She will talk us through all the safeguarded copy. I will try not to mutter to myself because I'm still sit very quietly.
I'm talking specifically about safeguarded copy today, and with safeguarded copy, we've released it in the past, and we continue to make improvements upon it. And one of the ones that we did with 9.2 was this new function, restore to production. So with safeguarded copy doesn't do you any good unless you can restore back. You'll have to do surgical type of recoveries, but when you have a catastrophic type of event and you need to copy full volumes back to your primary. That's what this function is to help with. So we'll be able to restore from a safeguarded copy back to a mirrored primary. And instead of doing the full copy, we will now support the incremental. So what we have here is before 9.2. You see we've got a full volume here on our primary volume, and it's mirrored, and the mirror can be a metro mirror, global copy, any of those three. And on the secondary, that secondary volume is what I would call is being safeguarded. And as you see on the secondary, we've got our safeguarded capacity, and we've got our backups back there. So as we, if you need to recover from one of these recovery points here, in the past, what you would have to do is restore back to the recovery volume, and then you would do a global copy, and that would be a full volume copy. And that would be quite a bit of data that's being pushed. With 9.2, what we have now is, and when you do select a recovery point, we will only recover just the change tracks that we have in the backup. So the nice thing about this function is that when you do create this relationship here, when you decide to do your recovery, it's a two-step process. It's a process where you do a recovery, and then the second process is a restore. So when you do the recovery, what it will do is it'll create this relationship very similar to just a regular safeguarded recovery. And when we do that, this recovery volume, that volume can be brought online. You can bring the volume online, make sure it's the proper recovery point that you would like. If it's not the proper recovery point, there's a very quick, you terminate that relationship, and then you can create a new relationship with a different recovery point, bring that online until you find the recovery point that you'd like. And once you create that recovery point, then you would issue a restore, and the restore will just send the incremental changes for that recovery point from that recovery volume to that mirrored primary. So by doing this, instead of pushing all the data, obviously we're going to have a significant savings in bandwidth and time. Got a question?
I was wondering, as far as those recovery volumes, let's say you go through and you take a look and that's not the one that you want. Is there just a command to put it from the recovery volumes back down into your safeguarded copy set? And before you pull the next one up and test that one?
So what it is, it's just it's very similar to our regular flash copy. So when you do that recover command, it just creates that recovery relationship. We don't have to copy any data over when as you bring that volume online. So when you terminate, you will release the space that you had if you allocated any space. And the only reason why you would allocate any space is if you had, as part of your IPL process, you might have written some tracks, and if you did that, then that might allocate some space, but normally it won't allocate any space. You would just terminate it, pick a different recovery point, and start all over. And everything in your safeguarded capacity, all those recovery points would remain the same. Nothing would be damaged.
Okay.
You would still be able to recover from any single one of those points.
Perfect. One more question. Well, for now anyways. In like a Metro Global Mirror environment, are you seeing customers where they're doing this, let's say at a Metro Mirror secondary, where they have a smaller subset of safeguarded copy, but a much larger, let's say a longer period of time at their Global Mirror destination?
So what we're seeing is that it's usually on a later legs of a cascaded environment. So, so if you have Metro Global Mirror, it would be on the Global Mirror secondary is what we're seeing, a lot of that configuration.
Yeah, some people,
Yes, at your DR site.
okay. Some people had been asking me if they could do a Metro Mirror secondary and just keep like 2 days worth. But they also wanted to have like the global mirror target and have that for like 7 or 10 days.
Right, and that is possible. That is absolutely possible. I thought you were asking about just most usage, but yes.
Sure.
And what we have seen is we have seen configurations where it's Metro Mirror and just in the Metro Mirror pair, and they do have safeguarded copy on both the primary and the secondary, so that this way when they do hyper swap, they have more flexibility to be able to recover.
Sure, that makes sense. All right, thank you.
Thank you. So just to sum up, it will work in Global Mirror, Metro Mirror, Global Mirror. Will also work with Global Copy, but Global Copy is not consistent. Thank you. It can be managed by CSM 6.3, and it is supported by GDPS as well. You do need a 8900 family with a 9.2. Just the box or the DS8000 that has the safeguarded copy needs to be on 9.2. So the primary box can still be an older generation like a DS8800 family, but the secondary needs to be an 89, or yeah, the secondary needs to be the 8900 where we have the safeguarded copy in order to take advantage of this function. One of the other improvements that we did was to come up with being able to create the safeguarded copy faster. Just that time to create the backup, we're just trying to constantly improve that to make that shorter and shorter. So one of the things that we did was to capture on that global mirror, in the global mirror leg, we do have a new way of doing things. So we'll just go over just some reminders of some of the topologies. So we have as Roger brought up, there's very many different ways you can configure safeguarded copy, but in a virtual isolated example, the one on the left here, it's virtually isolated, and because you do have on your global mirror secondary, on that same box, you do have your safeguarded copy. In a physically isolated environment, as we have on the right here, we would have a global copy to another DS8000 where your safeguarded copy is. And so that would be, a physical separation. And in that physical isolation, what we'll have here is you'll have global mirror, and then you'll have global copy going to that safeguarded copy box. In order to create the safeguarded backup that is consistent, what we'll have to do is pause global mirror, wait for the data to drain, and then we can create the backup. And that's how we would create the backup. And in this path, in order to create that, the critical path, as you can see, is in bold. So we would pause with global mirror with consistency. So this leg would be paused. We wait until it is paused. So for those of you that are not familiar with global mirror with consistency, pause with consistency, we have to wait for a consistency group to form, and then we can suspend. Then once the global mirror pauses, then we have to query out the global copy pairs until all the data is drained. Then we suspend the global copy pairs, and then we can resume global mirror. And because we've suspended this, then after that, we can take the safeguarded capture at that point. So the new solution is, instead of this pair being a global copy, it's going to be a global mirror. So it shortens the critical path that we have. So what we'll do first is we'll pause the cascaded GM with consistency. So we'll pause this here. Then we'll pause production. We'll pause this with consistency. Then we'll query until this pause is done. And once this pause is done, we can query, make sure the global mirror is also paused. And then once they are all paused, then we can resume the global mirror, the production global mirror, and then form the safeguarded copy. So it does shorten the time. Most of these queries are going to be, now we have system queries instead of volume queries, because when we're querying ooze to drain, those were volume level queries. Now, when these will be system level queries to make sure that the global mirror has paused. So there'll be more of an LSS based query instead of a volume based query to speed things up. All right. Oh, yes.
Notice on that, on the first global mirror, you have CSM there. Does GDPS support this as well? Having two global mirrors?
Not today.
Okay.
I'm not going to commit this for them,
Okay.
but
Roadmap.
it could be on the roadmap. So, but I'm not going to commit for GDPS. But
Okay.
this is a CSM solution. Yes.
I was also wondering, as far as the larger cache sizes, did you guys really increase the cache to be able to do a lot more of this functionality as far as safeguarded copy and bringing things back to recovery volumes and stuff like that?
Yeah, that helps quite a bit. With any of our copy functions, it does take quite a bit of cache in order for us to do the copying. To make the copying faster, to help that process. When we're transferring between with mirroring, having a larger cache size means that we can really keep those links busy, transferring data and not spending time trying to stage data into cache. And so yes, the cache sizes help quite a bit. It also gives us more non-volatile data. So having the non-volatile data also gives us an ability to not have to go to the disk so often.
Okay. Sorry, I have one more too.
Sure.
Let's say can you maintain replication while you're doing a recovery, let's say from a global mirror secondary? Because I mean, obviously the links are bidirectional, so can you be doing a small recovery, let's say a portion of a volume or multiple volumes, be let's say running that recovery process to production, but still mirroring everything else?
So with, I'm assuming you're talking about the restore to production
Yes.
feature. So I'm going to go back. With the restore to production feature, when we are in this scenario, if you're talking specifically about this volume here, this pair is going to be suspended. There's not, if you're going to do this catastrophic update, you're not going to really be updating RS1. So we don't see a use case for anyone to be able to want to do that. If you're not restoring to the volume, if it's not included in the session, it's not going to be affected. But if it's included in the session, it's going to be suspended. So and And it will be full volume because it is mirroring, and mirroring is almost always full volume.
All right, thank you.
Thank you.
And I will also mention that there is a GDPS session this afternoon at 2:30.
Is it 2:30 or 2:15? Don't want people coming in late. Come on. All right, so silently, I sent feelers out to my compadres to answer some of the questions I couldn't answer. So to your question, can you do an MES upgrade from the 8950 to the 8980? You cannot. But if that is something you would like, open an RFE. Kind of get it out there. Fair enough, fair enough. Okay, you'll take pity on them. Thank you. And then to your question, there aren't anything new in like the RMF records that you wouldn't already have for doing software mirroring, but there is, you will see more IO activity on the secondary using consistent read. There are the SMF 42, 5, and 6 records. They've got some new statistics. So you'll see that the number of HPF consistent read requests to the secondary, the average HPF consistent read from secondary, the number of hyperlink read from secondary attempts, as well as the number of Z hyperlink reads from secondary successes. Okay. Hopefully that was quiet. There was no clicking, not like when I use my keyboard and annoy everybody around me. So we've had a lot of discussion with safeguarded copy about what are the use cases, how do we do that, how do you properly recover, what kind of consistency do you have, and we wanted to take this opportunity to point out an excellent tool to do that, which is the IBM Z Batch Resiliency, or IZBR. So you probably know them for their operational resiliency and disaster recovery offerings, aspect of it where they can protect non-database managed data, have a lot of great real-time analysis, and be able to do an inventory of physical and logical backups. They've got a lot of good insights that can be reported and automated recovery, but they've extended how beneficial they are to enhance the IBM Cyber Vault solution. So now they're able to have an inventory of all of the data sets in a safeguarded copy backup and a lot of information around that. They've got some great tools to be able to detect issues or validate the data you have and help to automate the surgical recovery of any data set. So it's important to point out that this is more than batch. This is your database managed data, such as with DB2 or PDS or VSAM. They are able to do, to really understand what's in those safeguarded copy backups. They have their patented 3D virtual catalog. That is how they do the inventory to understand what data sets or jobs were running, to understand whether or not the data set was open or closed, what the original volume was. And from this, they've got tools with their health check report that will do that data validation. So when you talk about cyber resiliency and some of the main tenets of cyber resiliency, you're really looking at how do you understand that you have had a corruption? How do you recover from that? Take regular checks of your data. So you would create your backup and then periodically check for, validate your data. So something that is very important on this data is how do you verify it? How do you validate it? So the health check would help with that, and it also has a lot of information that can be used for forensic reporting so that you could identify if there is catastrophic issues or surgical issues, and then at what point do you need to go back and what is the impact both on determining where is the best recovery point, as well as what needs to be done. Do you need to rerun batch? And it also loops in with tape. It's important to include tape in this whole big picture because it may affect how you have to use some mitigation with tape as well. So it really gives you the ability to get your arms around all of the data that you may have that is impacted by some sort of an event. And even if you don't have an event, it gives you that level of reassurance that your data is what you expect it to be and have that ability to do regular checks. And so, there's a little more detail about what is possible with IBZR. See, at this point now I'm going to get tongue twisted. This is not like my normal presentations where I've got to talk about hyperlink write, hyperswap, where I get those confused. I'm going to call it IBM Z batch resiliency, and we will get that out of my mouth properly. And so, so I guess this is good advice that I was given before I started this, which was do not drink that cup of coffee. So God only knows. So this gives us a lot more detail that we are able to use the 3D virtual catalog to get that inventory, to really understand what were the jobs and the applications, what was open, what was closed, so that you have the ability to know, okay, I can protect from this point. Having the original volume as well is very important. And interesting to me, I think this is fantastic that you have the ability with this to automatically generate accurate restored JCL. So that makes the job much easier for our clients trying to recover. The health check allows for understanding what is open at that time. And then you've got the forensic ability with the timeliner report, with the forward cascade, the reverse cascade, to make sure really what was active and what are you going to affect. If you restore in one area, are you going to impact downstream as well? And this will help you identify, do you need to rerun batch? And what is the impact from your recovery point? So having these tools at your disposal really leverages what we're providing with our safeguarded copy backup and gives you the ability to use CSM with safeguarded copy and pick the right place to restore, run the reports to know what's beneficial, and have a better, smarter way to automate it. All right, switching gears now to transparent cloud tiering. We have grown our offering to now be able to cover 8 different cloud targets. So you can have a combination of off-prem, on-prem S3 cloud object, as well as the DS7900. This way, users can split their TCT backup and archives. And that allows for different service agreements. It allows for separation for test and dev. Security levels can be also affected by that. And multiple applications aren't going to want their data to be in a shared cloud object store. So this really allows for that division, especially in a multi-tenancy environment. And again, there are some DFSMS APARs that go along with the offering here for 9.2, but I will put my normal caveat of just double check. There may be more maintenance to find the right levels, but these are the minimum levels required. And so that we do within the DS8K share the resources, threads, and memories between the configured clouds, and you can have both connectors, the TS7700 and Cloud Object Store running at the same time. You are able to have those cloud targets uniquely identified with their cloud name. So you may want to have multiple TS77 grids so that you can have that separation of production and test. Might want to keep it separate for public and private cloud. That way you can have some confidential data on site and have that very well encompassed versus the data that can be stored in a public cloud. You are going to have different performance characteristics that you may want to consider, application separation, and different managed service providers depending on your needs. Yes, sir.
Is there any exposure to connections to these clouds in the TOS operating system, performance or availability reporting?
Is there any exposure to the ZOS?
Like a record or an electrical log?
We do have it encrypted, so it's not that you can sniff it.
So is that available on the TOS side?
It's available on the DS9700, and it is something we're working toward for the cloud side as well.
So you could send it in the DOS and merge it with SMF records?
Merge it into you're having a cloud that is, this is to move away from ZOS from that perspective. So it would be more like a cloud that the customer has. It could be a ZOS cloud, IBM cloud, or other things of that kind.
All right, the availability of the cloud into this environment, that you can consolidate your reporting on the SMF side, with the other availability reporting with, RMF device metrics and things of that sort.
So I hope some RFPs support this, but it's not available yet.
So the answer is no.
Yes.
Thank you for being ahead of me.
But you can vote on those RFEs, so that that helps bubble it up too.
And by the way, RFPs migrated to IBM.
Okay, I got the old stuff, like so much stuff moves around, so thank you. Yes,
So when you say that there's multi-cloud support, is there multi-cloud support on a DS8 as well? I can have multiple clouds there. And if so, is that securable by resource groups like the LCUs and everything are?
right, that's a good question, because I know that you host, and so multi-tenancy is important to you. And so from the DS8K perspective, those clouds those cloud names are set up ahead by ZOS with HSM, and they use the REST API to do that, and then they will use those cloud names. So there is that level of it, but there isn't resource groups per se.
I'm looking at more from the DSA side itself.
I'm not in that position anymore. I'm still curious about it though. I used to be a managed service provider with multi-tenancy. So we secure our multi-tenant global mirror box with resource groups. And I was just wondering if I have multiple clouds on there, if I could secure it the same way so that somebody coming in with the user ID wouldn't be able to see anybody else's constructs. Right, but can a user that comes in and say they only have access to resource group 15, can I connect a cloud access to that and only be able to see that? Or would I be able to see other things out there? Okay.
We have internal key management for the encryption of data at rest. So that will, depending on your need, reduce your need for external key manager. So those costs and management, that can be a prohibitive impact some of our customers. So this way you have the ability to encrypt your data on the drive. It does protect against many different cases. Of course, if somebody, it protects really from somebody walking away with your drive. If they are going to walk away with your KEC or your DS8K, I think you need better locks. People walk away with your KECs or your... I doubt it. I hope not. That seems like a heist movie, like The Italian Job. It's not gold bullion, it's a whole DS8K. Yeah, no, absolutely, right? So when you're looking at what's the scale of somebody's, if you have a trusted insider or something, having your drive protected, that has value. But your whole box, I guess it depends on whether or not you have a gym on site. Yes. It does. I feel like I have my straight man here. So you would order with the initial system. It's going to be feature code 0405, and you will need release 9.2 or later. You can rekey it, but you cannot have both external key management for data at rest with internal key management. So you can have one or the other for your data at rest, but you can intermix external key manager for things like EDIF, TCT, so forth. So it's local to the DS8K. We've got it redundant. I believe there's 8 copies. It's much more cost effective, simple to configure. You know, you don't need a USB key, any of those kinds of things for your data retention. Doesn't affect how the encryption works on the DS8K. It just affects where we get the data key. Now, I think I am just about out of time, so I'm gonna cover this quickly. There's a few more slides, but this is much better than my virtual share where it was joint between myself and Lori Goodall for the DS7700 and barely got through like the first set of charts. So I will be putting these up later on today, and if you have questions, our contact information is on it. So the last point I'm going to make is around our fiber channel connectivity report. This is going to give you the ability to kick this off via the GUI. It's going to give you a lot of interesting information about your attached ports, your host login information, replication login. It's going to tell you your security status. And that way, if you're in an audit mode before you start running with enforcing authentication, you can see, oh, wait, I have some ports that are not configured the way I want them to be. And if I were to turn on the enforcement, it would cause those host logins to log out. And that is something you definitely do not want. Or you could identify, like, I've got some stuff connected that I didn't realize and I should go clean up. So you are going to give a lot more information in a graphical way to understand that SAN connectivity and to be able to deploy the endpoint security. You've got information that's really going to be very descriptive and help you understand it. It also does help us from a debug perspective. And so we've got a very regular collection of that data. We will aggregate it, and then we will report it based on interface ID. You can export it. You can run it against your favorite format, if you like. And so this would be an example of some of the steps on the GUI as well as the report.
So that can be exported into something and then put it into maybe TOS reporting into a database.
That would make sense. I think we're really looking at putting it like in an Excel spreadsheet that would be more, as the user, but you could then look at how else to export.
Merged it with RMF data and made it enhanced RMF data, along with there's another reporting facility I saw about 20 slides ago.
Okay.
That data too would be interesting, all the
Yeah.
back-end consumption patterns and all that.
Yeah.
Because it's freaking,
It's a lot.
it's mystery sometimes.
I'm going to take that back.
And there's silos between the storage group sometimes, the capacity group,
Yeah.
to understand response times. And so being able to merge that data, although somebody has to be like the ambassador, shaking hands, the
Yes.
UN,
Yes.
shake hands and all that.
That's good information. I'll feed that back, to see what can we do to sort of optimize aggregating information. RMF device stuff. Yep.
Device. And that would be, advantage factors to other
Yeah.
options.
All right, I like it. Thank you. I know Teresa's taking good notes, so. All right, well, now that I've probably come exactly to the end, any last questions?
I was wondering, besides cache size difference, what's the difference between like an 8950 and an 8980
So,
besides cache?
so for the cache, you also have more cores from 40 to 44. So you have more threads that are available, like for the advanced features of safeguarded copy or for hyperlink or TCT. There's also some performance boosts for the HPFE backend. So there's a few areas there that have been focused on from a performance perspective. So it would be the fastest, highest performing with those differences. Thank you. All right, well, thank you all. I appreciate your time and attention.
And
I
please remember to
appreciate
fill out
everyone
your
on board.
evaluations.